Good morning, everybody. This is going to be a review of a short paper of Dr. Viv Robinson's on moving clocks and special relativity reference frames that was sent to me a few days ago. I'd just like to start by saying very briefly that I thoroughly enjoyed this short paper, and I remember, and it's referencing a problem which both Dr. Robinson and I addressed some years ago, where we noted that a lot of people who perhaps should have known better didn't seem to have the kind of understanding of relativity that we thought every competent physicist should have. And Viv's put down in words here pretty well quite a lot of the answers that those people should have seen themselves in thinking about rest reference frames. So I enjoyed reading the paper, and the long and the short of it is that I recommend that something very like this, certainly, if not this precisely, should be published. But I'm going to go through it now, having said that I'm happy with the paper, to say what I think's wrong with it. And the first thing I think that's wrong with it is the title, because during the argument, as Viv takes us through some of this stuff, he brings in more than is expressed within the title, not just special relativity, but also aspects, very briefly, that they may be, of general relativity. So I think going for relativity here rather than special relativity might be worth considering. What do you think, Viv?
Oh, I don't have a problem with that. I wrote it in response to somebody else who had clearly the wrong idea. But yes, you can't talk about different velocities of the planets without bringing general relativity corrections into them. So I have no problems. I've just crossed out and special moving clocks and relativistic reference frames.
Yes, beautiful.
Okay, great.
Both a shorter title as well. I'm always in. Okay, good. Right. There is one thing, and this is a personal preference that I have, and not everybody agrees with this, but one thing is the argument kind of developed, and it was a bit like a mystery novel, which is in terms of what was going to come up next. But one thing I like to do is try and address exactly what point I was trying to make in the paper as a whole. What's the main result, or what are the main results of that paper? So I like to put that quite close to the beginning and then sort of repeat it near the end. And you don't need to be quite as unsubtle as I often am in my papers and say, the main result of this paper is, and then say what the main result of the paper is. That doesn't have to be that unsubtle, but I missed sort of that at the beginning of the paper, and then near the end to say what is the topic for discussion and what has been concluded. What do you think, Viv, anyway? Is that something that
Yes, well, I did give a bit of a summary and conclusion where I'm essentially saying that for special relativity, the stars are fixed for thousands of light years away, and because any form of space traveler would have had to originate from a planet around one of those stars, there's this slightly fuzzy area of a very small amount where they could otherwise not know who is traveling the fastest. But for the rest of it, anything outside that, both will know exactly who is traveling the fastest with respect to that reference frame. And I back that up, of course, with cosmic rays. I mean, nobody suggests that we're moving through the universe at some phenomenal rate and banging into all the cosmic rays. The cosmic rays are moving at a phenomenal rate to us.
That's right. Yeah, that's correct.
And there is no confusion with that.
There isn't, you're right. And do you want to mention Mach's principle and the cosmic? I think you mentioned the cosmic ray microwave background at some point.
No, I specifically mentioned cosmic rays. I don't refer to the microwave background.
Do you want to mention that? Do you want to mention that?
It is down there.
Is it?
Yes.
Uh-huh.
It's under the section of reciprocity.
Reciprocity.
Second paragraph. Yes.
Okay. I missed that one. No, in that case, no comment on that. That's. I didn't expect to go into that too much, but if there's a mention in there somewhere, that's absolutely all that's required, I think, on Max principle at this level. There's another thing I missed, and probably I simply missed it and that was a discussion on if you're sitting on some planet and you're sitting in that every observer is sitting in an inertial reference frame of their own because they're in free fall. And that in that reference frame, there are a couple of things going on. One is one may be moving with respect to the fixed reference frame, that we like the fixed stars or the universal reference frame or the center of the microwave, cosmic microwave background, all slightly different, of course. But each one of these possible observers is sitting in a different inertial reference frame. That inertial reference frame may be embedded in some movement field, some photon field, or it might be embedded in some mass field, some gravitational Mach principle-like field. But for all of them, they're in free fall, and they're all perfectly good, in that sense, inertial reference frames. Do you want to say something like that at any point?
I tried to get the message across that the so-called inertial reference frame is the centers of masses of all of the stars for a few thousand light years away. That is a fixed reference because none of the stars are moving with respect to each other.
Oh yeah, okay. No, I understand that part of it. But what I'm saying is, okay, given that there is that fixed frame, which we can define in terms of the motion with respect to those fixed point stars, which is a moving frame, or which is a motion frame rather than a moving frame, which is a fixed frame of motion with respect to those stars. I'm wondering if you want to bring in also the idea that any observer within that system, however they're moving with respect to those fixed stars, is also themselves in their own inertial reference frame with respect to themselves because they're in free fall. Do you want to say that and say that nonetheless can be related to this fixed reference frame, which is
I was implying, but not specifically stating that everything can be related to the fixed reference frame. I'll give you the example. People have often said, whatever is being accelerated is moving. But I say, no, get yourself talk to some entrepreneur somewhere and get access to a rocket and build yourself a pair of accurate timers, put one of them in the rocket and shoot it in retrograde orbit so it stays in the same place. And Earth needs solar sail, of course, to keep it at that distance. And Earth, so it stays there. So you've got Earth going this way. You accelerate back that way. And so it stays in fixed place. When Earth comes round again, you'll find it's about 0.32 seconds. The Earth clock has run 0.32 seconds slower. So so acceleration's got absolutely nothing to do with it. But there is this, as I say, the inertial rest frame, 2,000 or 3,000 parsecs. I think you've got to go at least that far before you start to see a slight wander in some of the other stars. Anything that comes in our direction, originating from within there, the only difference will be the motion of the planet around the sun, around their star, where they form whatever instrument it is that they're traveling, or vessel there is they're traveling. That's the only variation. And if one of them's got up to 3/4 of light speed, well, good luck to them. They will know they're travelling fast, and the local earthbound traveller is relatively slow. There will be no question about that.
I take your point about the retrograde orbit, and I think that's a fun thing. To have a look at. But you make a further point later. I don't remember whether it was actually later in the argument or earlier in the argument. But another thing that happens is the relative rate of change of clocks as you immerse yourself in a gravitational field. And of course, the strength of that gravitational field is also going to affect the rate of motion of those clocks.
Yes,
that's a good one.
Suggest I give a talk on a journey through relativity.
I think you have done.
This paper has been partially that, yes, but there's a lot more to it than that. But
you just wanted, if you just wanted to, okay. So, and this is a decision that I think you should make in terms of how you present this. If you just want to look at the special relativistic corrections, which is of course what it was originally in the title, then perhaps you should say somewhere near the beginning, we're going to discuss general relativity and the effect that has on the rate of change of clocks. But here I just want to look at the misconceptions around special relativity. You could do that, and then it would be just the special relativistic bit. I
think probably the one that I have missed out a bit on. A tremendous number of people who just have not a clue how Einstein derived his thing are very, very critical of it. Of his work, both special and general relativity. Now, I don't agree with everything he says in general relativity, not by a long way, but I understand how he derived it. I understand what he was saying. Special relativity, though, forget about it. What he said is correct. It stacks up against experiment. If you have any difficulties about which one is moving faster, then you've got this inertial frame of reference, which is the center of masses of all of the stars around us for several thousand light years, and that is fixed. The fact that we are rotating with the galaxy has got nothing to do with it, unless something comes from somewhere outside that.
Both listen to yourself. Re-listen to the bit you just said. Beautiful, eloquent, to the point, saying what you wanted to say. I think writing a sentence almost exactly like the thing you just said, in the bit that it stacks up, that would be beautiful.
I'll do that. Well, this is the advantage. I always find it more advantageous to be able to present something to someone, a live audience with responses, but it's not really possible every time. So I do my best and then try and fix it up later. No, but I agree with you. You get all of these otherwise intelligent people saying, look, Einstein, it can't possibly be right because there was an error in the Michelson-Morley measurement, or there's some other thing.
I know.
Forget it. All of that does nothing more than indicate you haven't got a clue. You don't understand.
That's right.
And I think just accept it and move on.
You have to realize, one has to realize that one doesn't understand everything oneself as well sometimes, and there's always room for looking at subtlety but you have to start with the starting point, and I think this is perhaps one of the main results of the paper, that people have a view which develops over time as to what things are about, and that view is consciously or unconsciously influenced by the media perception of what's going on, of what this means, of how mysterious this all is. And I think in the discussions that we've had with a wider group on special relativity, I think a lot of that's come out about the actual shortening of rulers, which doesn't happen, and this sort of thing, which is part of the problem that you're trying to address. You're trying to address here. So perhaps saying something like that. Well, actually, you do say something I do think you should take out at some point in the complexity bit. You write down, and this may be true, but I don't think you should say
I like that.
You write down, I think the quote is, most mathematical physicists don't understand it, you say. Now, this is not the best way to make friends and influence people necessarily. People who consider themselves.
Make friends. I'll have a look at that. Many don't understand it. Some don't understand it, something like that.
What I would do is do the Maxwell on this, which is say that something along the lines of many in discussions, it's become clear that many others had not considered this particular question as deeply as they should have done, or what was it? Another one of his. Had the others reasoned better, they would have realised. or had others reasoned better, they would have realised. Something like that, where you say exactly the same thing, but everybody, instead of thinking, "Hey, I'm a mathematical physicist, I understand it," they think the others are some other, if you see what I mean. But of course, they're not really. Anyway, I think I would take that out. Just that phrase. You do that quite often, and do you know what? I enjoy it in private, because normally I think, yeah, that's right. But I think in public you want to keep that sort of thing a little bit moderated.
All right. I will certainly take up your suggestion of Maxwell's ways around the problem, ways of saying the same thing without offending.
Oh, there's a typo on page 2 as well. Not a typo, but a sort of bit of missing text.
Okay.
It's the paragraph that begins, "Consider 2 accurate clocks, D and E." Something in there. Just a minute. What is it? That one? No, it's the next one. Consider a situation in the far distant future. That one. Beyond the small planetary, both travel age with a similar. You're going to say similar what?
Would originate with similar rest reference frames, having a time difference.
Just there's a word or two missing there. That's all. Have a look at it.
Oh, was there? All right.
Yeah. No, it's obvious what you mean, but it just not quite.
I'll have a close look at it.
Yeah, just have a look at that. That's. Well, you know what? Let me just check. Yeah. Oh, yeah. There was one other thing. Are you intending this piece to be a didactic piece where you're just teaching people stuff that's not really saying anything that people shouldn't know already? Or is there something there which is a slightly different view of relativity that you'd like to, of serious relativity? I mean, not the stuff where people aren't really getting it, that you'd like to bring out. You know, the 1 + Z, 1 - Z argument, for example, that you just talked about. Would you like to bring that out specifically? As a result, as one of, or the main result. Are you going to agree?
I think I need then to go back and have another look at possibly how I should rewrite, because I've stated most of the things I want to say. I think I need to rewrite them specifically aimed towards saying what I was setting out to achieve, and then going through and then saying what I have achieved. One of the things was just straight out, as you would say, Maxwell would say, getting people, if they thought more deeply about it, they would come to the same conclusion. And the second one, as I've seen referred to, I've heard referred to many times, is the difference between the rest frame reference and the moving frame reference is due to the acceleration. I'm saying that's not due to that at all. I'm going to give that example. Well, maybe you can talk one of your friends into funding that experiment.
It's a lovely experiment, and I like it. But I think there's a subtlety there, of course, in that it is, as you accelerate, you do change reference frame.
For the short time of the acceleration, yes, it becomes as if you're in a field of gravity, yes, but it's for such a short time.
Yeah, but you can change it either way, is your point. If you move if you go to a retrograde orbit, you could change it into a direction where it was actually in the opposite direction than if you went in the same direction with the orbit. Is the point you're making there? And
you could do a double retrograde orbit, and you'd get the same. And when they came back and met up a couple of
different.
loops, they'd be the same time. I don't know why. It'd be interesting to see if anybody wanted to do it. You and I know what their answer is anyway.
You mean going twice as fast around the wrong way? That would then be the same time. That's right. Yeah,
it would be the same distance, the same reference frame. Yeah. It'd be same velocity with respect to the. That would be an interesting one.
I think that would be a nice way to put it, wouldn't it? To say, if you accelerated it up to that, then it would go the direction up to a maximum, and then it come back and agree again.
No, actually, no. If you doubled it, it would be because it's in the opposite direction.
Right. Yeah, it would reach.
We need to think about that one.
You would need to, but no, I think it's right. I think you're right. I mean, it would come up to some maximum, then it would come back to agree, and then it would go further down the other way. I think that's right.
No, because the velocity. No, you would double. So accelerating in retrograde orbit to a fixed spot in space would make it about 0.32 seconds per orbit. But if you then doubled so we could get twice the acceleration, so it was going, no, because what is happening is you're going that way and it's going this way. So the speed difference is double the Earth velocity.
I need to think about
the difference between the difference between the two is double the Earth velocity.
Yes, that's right.
However, if you let one, say you did two accelerations, one settled a solar sail in fixed position with respect to the inertial frame of reference of the rest of the stars, and the other one went twice as fast, and the fixed reference with respect to the inertial stars would detect both of them as having a time difference of 0.32 seconds per orbit. But the difference between the two of them would be 0.64 seconds because they're going in opposite directions.
I think it's fun to discuss that one too. Why not?
All right.
You don't want to make it too
I suppose if we make enough suggestions, you might get somebody who wants to try and prove it wrong by doing an experiment.
That'd be so cool. Yeah, that'd be good to get some experiments on this. Anyway, look, what I suggest we do is have a think about that and decide what you want to take in. As I say, I'm happy putting this up either way, really, just as is. But have a look and see if you want to add some of or modify some of those things. Perhaps we can reconvene whenever you're ready and have another look and see if anything else occurs to either of us.
No, I think at this stage, the usual thing with the reviewer makes suggestions, the author accepts it or rejects it. The author accepts or rejects.
Well, that's one of the things we're going to
resubmit it. Yeah.
One of the things we're going to do this time that's different to the way anyone's done it before is the reviewer isn't going to play God here. I'm just going to argue with you, and we'll see who reasons more deeply in each and every particular thing, and then I'll agree to let the author go with his feeling, even if I still think I don't really get that. Okay, so in this case...
I will tell you, I think I've mentioned this, I was asked to review papers, I never rejected any of them. Well, my major comment was, if the author wishes his name to be seen in public with this, the mistakes, I won't stop him.
Well, look, I'd appreciate if you're ever reviewing anything of mine and that you use exactly that phrase. And I'm going to do the same thing to you too, okay? So,
no, I think it's better that way. Because there are so many.
No, you're right. Sometimes it's just. Sometimes it's just.
There are so many reviewers who just say, "No, I've got a theory that says your theory is wrong," or that sort of thing, and that's the end of the discussion. Your theory is wrong. That's
one of my favourites.
Yeah. So is mathematics is complex enough.
Yeah.
Or the other one.
Want some complex
there's nothing wrong with it. There's nothing wrong with it. There's not standard model. So look, we're not publishing it. No matter how far advanced the predictions were.
Well, we're going to do this differently, okay?
Okay.
Right, and thanks again. I enjoyed reading it. I was hearing a lot of stuff coming past, and that very long discussion. going backwards and forwards, mostly nonsense, of course. And this was addressing some of those points.
Okay.
Okay, that's it. Cheers.
Okay, thanks.